Assalamualaikum and good evening. Today, I and my group want to present or explain about singular joint using friction stick welding. So this is our group member, me, Muhammad Fakullah, then Muhammad Zahin, Muhammad Azim, and Muhammad Farid. So introduction, the metal joining process essential in most manufacturing industry since they can produce complex shape with different material properties. Welding is an excellent permanent metal joining technical due to its superior and properties compared to fastening and semi-joining process. Among various advanced welding operation, friction stick welding is an amazing and promising technical that originated from the Welding Institute (TWI) UK in the years 1991. The basic principle of FSW is entirely different for other conventional welding process. Second, in the conventional welding process, the base metal undergoes melting followed by solidification, whereas FSW produce metal joined by the solid state deformation principle. Moreover, the metal compared to other functions welding process, the FSW required minimal power requirement and pre-processing and post-processing effort. Next, abstracts. First, the permanent metal joining process play a vital role in assembling and complex aluminium structure of the aerospace, automotive, marine and oil industry. The second is the invention of friction stick welding. Redefine the mechanism of metal joining to produce high quality weld by eliminating the consumption of electrode and shielding gas resulting an economical process.
Okay, Assalamualaikum. So I want to explain about how friction steel welding works. First, for SW parameters, the quality of the weld is majorly influenced by the parameter associated to the weld, to profile, materials, and geometry of the weld. Second, for weld parameter, the parameter of friction stir welding attributes to the joining quality, tool rotation speed, weld traverse speed, angle of tool tip, and axial load. And third, the tool rotation speed, spindle speed, and the welding traverse speed are two main parameters responsible for the generation of heat and achieving weld quality in terms of the strength of the weld joint. First, about tool rotational speed. Cylindrical tool has to rotate to produce heat and move to carry the heat along the joint. Usually, the tool rotates in a speed range that varies from 300 to 3000 rotation per minute. Second is weld or traverse speed. The tool's traverse speed or weld speed varies between 5 and 400 millimeters per minute along the joint length. For the third, tool tip angle, the tilt is given to prevent the effect of downward force from damaging the joint. And for axial load, the axial load has a strong influence on the frictional force generated. So look at the example picture. I was put the picture. So that example. So next, this figure show different tool design profile used in friction stir welding process. For A is a shoulder design, like at the picture, and B is for tool pin profile. Though that include cylinder taper, SQ square, and SCFT cylinder full thread, and others. So this image is show how to rotate the pipe. So A is a pipe rotating approach, and B is a tool rotating approach.
So as we know, there are three advantages for friction steel welding. The first one is improved weld quality. Friction steel welding produce weld with minimal defects such as void, crack, or porosity. The process eliminate the need for consumable like filler material or shielding gas, reducing the likelihood of defect associated with traditional welding technique. So this improved quality is critical for circular joint that may experience high stress or pressure. The second one is increased process efficiency. So friction steel welding is a relatively fast process compared to conventional welding technique. The continuous and rapid motion of the rotating to allow for efficient joining of circular component. Lastly, compatibility with different material. Friction steel welding is suitable for a wide range of material, including aluminum, magnesium, copper, steel, and even some non-metallic material. This versatility allows for the welding of dissimilar material, enabling the joining of components with varying properties. Now let's move on to the next slide. Application. So application is pipe and tube manufacturing. Recent welding is utilized in the production of circular pipe and tubes, particularly for joining dissimilar metal along with varying thickness. This application find use in industry such as oil and gas, construction, and infrastructure, where the production of high quality relatable joint is critical. Now, I hand over for the next slide to Azim.
In conclusion, the use of friction state welding for circular joints offers several advantages and have proven to be a reliable and efficient method for joints circular components. FSW is a solid-state welding process that uses frictional heat generated by a rotation tool to soften and join the materials. Point to conclusion, one of the key benefits of FSW for circular joint is its ability to produce high quality well when excellent mechanical property. The process eliminated the need for fillet metal or consumable, resulting in the joint that are free from defects such as void, porosity, or crack. The absence of the melting pitch also reduction the risk of distortion or wrapping weld area. Uh, that that all presentation for our group about circular joint friction state welding. Alright, thank you.